All right, welcome to the Unit 3 test review, which is solving quadratics. So I'm only going to do the circled questions, but I have all the answers for the other ones, so you're more than welcome to look at them as we go through. All right, so number 3. For this, I need to get my like terms together to get the equation in standard form. So I have my x squareds together. I need to bring my constant over to the left side to be with the other terms. And oh my goodness, I put a plus. Getting late. So minus 2x squared. And we have 18x squareds left plus 27x plus 4 equals 0. So it's in standard form. I have my a, b, and c. They're big numbers, but I guess I should look before I did that. Is there a greatest common factor? Is there a GCF? And there isn't. 18, 27, and 4. It's weird, but they seem like they would have one, but they don't. There's no greatest common factor. So I would divide a greatest common factor out if there was one. There isn't, so I'm going to look at A is 18, B is 27, and C is 4. So I'm going to do my little X, just give us a little visual. A times C is 18 times 4 is 72. And B is 27, so about down here, put 27. I think what two numbers multiply to 72 that add up to 27? So I'm just going to start with 9 times 8, and that adds up to 17, so not quite. I'm going to divide 9 by 3 and multiply 8 by 3, and 3 and 24. There we go. Got them. 3 and 24. Now, if you are struggling, let me show you a shortcut. If you are struggling with this, you think about what two numbers multiply to get 72. So I can just make them x and y. These same two numbers have to add to get 27. If you put these in Desmos, I'm cool with this because we've struggled long enough. If you are struggling with this, I want us to get further. So x times y equals 72. And then x plus y equals 27. What I'm looking for is intersection, where they intersect. So 3 and 24, or here, 24 and 3. There's your points, so 24 and 3. So you're more welcome to do that. Now, from there, we have to use the Punnett square. So we have, in the top left is 18x squared. That's your A term. Bottom right is your C term. And in between, we write the 3 and 24. Now, there has to be the B term, so it has to include an x, because 3x plus 24x is the 27, so it's got to be the B term. Now, at this point, we're looking at our greatest common factors. So in your bottom row, greatest common factor, well, it's only 1. Because this 3 is positive, it'll be a positive 1, so bottom left. Then we do greatest common factor of the top row, and that looks like a 6. And they have x squared and x, it's always the smallest, so 6x. Greatest common factor of the last column looks like a 4. And because this 24 is positive, it would be a positive 4. And then greatest common factor of our first column is 3 and x. Now, we have 3x plus 4 as a factor, and 6x plus 1 is a factor. So I just rewrote this quadratic, the trinomial, as two factors. Set each factor equal to 0. Because if either factor equals 0, well, the whole thing will be 0 because it's multiply. Multiplying times 0 always gives you 0. So subtract 4, divide by 3, and there we go. There's negative 4/3. Subtract 1, divide by 6, and you get negative 1/6. Perfect. Cool. All right, so that's factoring. That's what you do for all of them. Solve it using a square root method. All right, square root method. Square root method is when you see that there is only one variable in the whole problem. So once you can get like terms together, and if you see only one variable in the whole problem, you can solve for it. So I'm going to look at, I have from the variable, I have a square. So kind of off to the side, I work with a square as my order of operations, then multiply by 2, or the negative 2, and then take the subtract the 10. So, or the 10 is positive, so it really should be add. All right, so I need to do the reverse of that. So I need to subtract 10. You could also look at this as those are like terms, the 10 and the negative 98. The negative 2x squared comes down, and negative 108. Then we divide by negative 2. And then we square root. And with the square root comes both solutions, because that gets rid of our square. And we need to simplify the square root of 54. Square root of 54. What's the biggest perfect square that comes out of that? So go to Desmos if you want. Check out 54. It's not a perfect square. No, of course not. We do 54 divided by, we'll go 16. Nope. 9. Yeah, 9 and 6. Cool, 9 is the biggest. So that is the square root of 9 times 6. The square root of 9 is 3. The square root of 6. And there we go. There's our answer. So number 6, your answer will be a plus minus 8 square root of 2. So don't forget with to undo this multiply by 1/4, you multiply by the reciprocal 4 over 1. All right, number 9. So here's again, we only see one variable in the whole problem, so we can solve for it. I'm just going to write off to the side from that variable what my order of operations are. I have inside the parentheses, so I'm adding 10. After I take care of the add 10, after that it would be exponents. So GEMDAS, we have inside the parentheses first, then you have exponents, so square. After we square, so that's doing the square, then the next operation is multiply by 2. So after you multiply by 2, then the last step would be subtract 34. So we have to do the reverse of this, reverse order. So start with subtract 34. So we add 34. Another way you could look at this as you need to get the parentheses all by themselves so we can drop them and get the x out of there. And you just have to do it in the right order. And sometimes that's hard. Negative 26 plus 34 is 8. But you guys can certainly do this. So the opposite of subtract 34, we added. Opposite of multiply by 2 is divide by 2. Check. Opposite of square is square root. All right, we got the plus minus from the square root. Now we can drop the parentheses because the square was what's keeping the parentheses there. And the square root of 4 is 2. Now we're not done with this problem yet, so we need to rewrite it as two equations. We have 10 plus, or x plus 10 equals 2, and x plus 10 equals negative 2. Minus 10, you get negative 8. Subtract 10, negative 12. Now your two solutions. Number 10, let's work that out. That one's a little bit different. Looks easier. It's not. But I think we got this. So first step, again, there's only the x's here. The parentheses, so from the x, you have multiply by 3. Then after you multiply by 3, order of operations would be to add 2. Because inside parentheses means start order of operations over again. After you add the 2, then it'd be the square. So we have to undo that. Square root first. Okay, so we have 3x plus 2. Looks easy. Square root of 20. Square root of 20 breaks down into the square root of 4 times the square root of 5. So that becomes square root of 4 is 2, square root of 5. Okay, we have two problems here, or two different equations that we need to write. We have 3x plus 2 equals a positive 2 square root of 5. And let me write this in a different. We have 3x plus 2 equals a negative 2 square root of 5. So we do have to solve both of these. Similar steps. So subtract 2, subtract 2. I will actually, my answer has the 2 in the back. I'm going to put it in the front. So negative 2, and this is a positive 2, so plus 2 square root of 5. I prefer it in the front because if you put it after the square root, they could be confused if the square root's too high, too far. So after that, then we're going to divide everything by 3. So it's x equals a negative 2 plus 2 square root of 5 divided by 3. And then over on the other side, in purple, we have subtract 2. Again, I'm going to put this, the negative 2 before and there are my two solutions. Now you see they're very, very similar. The only thing that's different is the plus minus. So if you wanted to write these together, you certainly can. To write them together, it'd be x equals a negative 2 plus or minus 2 square root of 5 divided by 3, which is where you get it from the quadratic formula. Cool. All right, 11 and 12, here are your answers. You have 7 plus or minus the square root of 5, and 7/20 and 13/20. 13, 14, you got some imaginary answers, but I think you can work those out. Number 15 is 12i squared root of 2, so you're just breaking out the biggest perfect square, the 144. Number 16, haven't done a problem like this for a bit. So we were subtracting complex numbers. And this subtraction here, think of it as like a negative 1, and I'm going to distribute it in. First, this first parenthesis is not needed. The only reason why it's in parentheses is because it's a complex number, and it's just saying it's a complex number. It's put together. But there's no multiplication, no exponents, no subtraction, so I don't need the parentheses. Now, I need the parentheses in a second because we're subtracting each term. So when we distribute here, negative 1 times 1 is negative 1. Negative 1 times a negative 2i is a positive 2i. Now let's get our like terms together. I have negative 6 plus minus 1 is negative 7. I have 10i plus 2i is 12i. And there you go. That's it. All right, number 17, I'm going to work that one out because I'm paranoid with this one because I got it wrong when I was in school. Anything squared means that base times itself. So you need to rewrite it out. A lot of you, I did this with the Punnett square, so let's do it with the Punnett square. We have 2 columns because we have 2 terms in the first binomial. We have 2 rows because we have 2 terms in the second binomial. That's why they're called binomials. Crazy, huh? 3 times 3 is 9. 3 times negative 2i is a negative 6i. 3 times negative 2i is a negative 6i. Negative 2 times negative 2 is positive 4. I times I is I squared. Now, your like terms should be in diagonal here. So you're adding always. So we're always adding. Think of it like this. You're adding all these together. So negative 6i, negative 6i is a negative 12i. Now, in the bottom right, we have an I squared. Just remember, I squared equals negative 1. So this is 4 times I squared, so it's really 4 times negative 1. Well, 4 times negative 1 is negative 4. And now we have another set of like terms. We have 9 plus negative 4. 9 plus negative 4 is 5. Always write the real number first, and then the imaginary. So negative 5, or 5 minus 12i. And our second problem is going to be done very similar. It'll be 10 plus 10i. Number 19, not going to work that out, but it's 5 plus or minus I squared is 7 over 2. Number 20, I'm going to work that out, I guess. I got it circled. So let's work it out. So I have to get in, so I can't do this by square root method. Looks like I want it by solve each equation. So let's see. Let's move all the terms to one side. Let's see what we got. 7 and 1 are like terms. I am going to quickly do A, B, and C. A times C is 40. Well, first 5, 4, and 8. There's no like term, no greatest common factor. Do I have two numbers that multiply to 40 that add up to negative 4? So I'm just going to do it quick. 4 times 10, no. 2 times 20, no. 8 times 5, no. I don't see anything. So let's go to the quadratic formula. So the quadratic formula is x equals the opposite, negative b, plus or minus the square root of negative 4 squared, minus 4 times a times c. So I could not find anything real quick to factor. 2 times a. You could be thinking, well, Mr. Johnson, why aren't you just looking down here? There's imaginaries. Of course you can't factor it. Well, true, but I didn't know that. I didn't know the answer if I was doing this problem right away. So opposite of negative 4 is positive 4. So I try to simulate what I would do as a student. So negative 4 squared is 16. Negative 4 times 5 is negative 20. Times 8 is negative 160. Divided by 2 times 5 is 10. We have 4 plus or minus the square root of negative 144 over 10. Let's simplify the square root of 144. That is just 12i. Square root of 144 is 12, and that's I over 10. And then let's simplify. So I have x equals, divide by 2, divide by 2, divide by 2. And there's my solution. All right, number 21, there's your solution. 22, there's the solution. 23, there's the solution. And 24, there's the solution. None of these can you simplify by anything but the square root. Or not the square root, by the quadratic formula. So the only way you can do it by quadratic formula is if you had, by factoring would be if your answers were